Hi everyone, my name is Aree Tongloet. Today I'm going to say what is a state of factor controlling composite failure of hybrid composite. So the first thing is I want to give a brief introduction of this study. So basically, as we know that hybrid composite has been studied to improve the mechanical properties of the composite material. But as far as we know that the composite failure mechanism of hybrid composites is not well understood. So this thing aimed to the study is to investigate the failure characteristic of the slick hybrid composite and to investigate the possible factors controlling the failure characteristic of hybrid composite as well. And this is overall test that I have done so far. So basically, I use sandwich beam containing the top layer as a hybrid composite, the core material and the bottom skin is made of iron F552. This experiment uses 3 different hybrid systems, which are M55J with S-glass, TC30T with S-glass, and another one which is a carbon-carbon hybrid composite containing 34700 and HR40. And I performed the test under 4-point fracture test to observe the failure response of hybrid composite at the top skin. And after the material reached the failure, I sectioned the failure to observe the failure characteristic under microscope and scanning electron microscope. And this is the result that got so far from 3 different systems. As you can see on the left-hand side is a response from F55 hybridized with S-glass. So you can see that the response is nonlinear, including you may see the knee point on the response. And when you have a look on the failure, so you can see small carbon fragmentations on the hybrid system. And I found that the failure of M55J has been improved from 0.3% to be 0.7%. And the middle of presentation, you can see the failure characteristic of TC33 hybridized with S-glass. As you can see that the trend is nonlinear as well, but the failure is fiber splitting, delamination, and king band on this material. And the failure strength is improved from 0.5 to be 2.6%. And the last one is the carbon-carbon hybrid composite, which is containing HR40 and 34700. You can see the failure trend is nonlinear as well, but the failure, as you can see on the presentation, is single angle crack and the evidence of king band. And this material creates the failure strength to be improved from 0.58 to be 1.13%. As some conclusion from this presentation, I found that composite failure strength of low strain material has been improved with hybridization concept. And the second key point is each hybrid system in this study create a different failure characteristic. As you can see on the right-hand side, M55 hybrid create a fragmentation, TC33 hybrid composite create fiber splitting and delamination, including king band. And the last one, you can see just only single angle crack with the evidence of king band. And again, the failure characteristic would be driven by low strain fiber. As you can see that there's only one hybrid system, which is an M55 hybrid composite create fragmentation on this material. And the future work, actually, I just finished the test last week, so if you feel free to see the failure looks like, you can go to my poster. So my future work is study another hybrid system containing S-glass with HR40 to see what the failure looks like. Is that small carbon fragmentation or single angle crack, or is there any significant change on stress strain response of the material? So this thing will come to another second point, which is I will compare the failure. I will compare this result with previous hybrid system to analyze another possible factor controlling the failure mechanism of particular hybrid system. Because the thing is, I would like to investigate the key factor creating multiple fragmentation on this system if S-glass hybridized with HR40 create fragmentations. And thank you for your attention. Feel free to ask questions.